everyone and welcome to this video. My name is Cliona, I'm a H1 chemistry student and today I'm going to be taking you through the solution to question 6 from the 2021 higher level Leaving Cert Chemistry paper. And this question is based on the chapter on fuels and thermochemistry. So let's get started. So we're told that bio-LPG is a co-product in the manufacture of biodiesel from renewable crops and domestic and industrial waste. And we're told that hydrogen gas is a reagent in the product of these biofuels, okay? So question A is broken into two parts and it's 11 marks altogether. And it asks us to give two commercial sources of hydrogen gas, okay? That's basically just two ways to obtain hydrogen gas. And the second part asks us to state two main advantages of using hydrogen gas itself as a fuel. So let's give those a go. So here we have part 1, which asks us to give two commercial sources of hydrogen gas. So the two I gave were the electrolysis of water. So you might remember doing this as an experiment for your junior cert, when you basically split water into hydrogen and oxygen using electricity. So you're going to get 3 marks for your first answer, okay? And then 2 marks for your second answer. And the second answer I gave was the dehydrocyclization of hydrocarbons. So you'll remember studying this in the fuels and thermochemistry chapter, okay? And it's basically when you're converting straight chained hydrocarbons to form ring compounds, okay? So this is a solution to autoignition, if that makes you remember it. And the byproduct of this is hydrogen, okay? So that's another way of obtaining hydrogen. Okay, now question A part 2 asks us to state two main advantages of using hydrogen gas itself as a fuel. So the two I used were there's a plentiful supply of it, so that there's plenty hydrogen in the world, and also it's very efficient. And what we mean by very efficient is that there's a very high energy produced from hydrogen per kg, okay? So for this you're going to get 3 marks for each of your advantages. So plentiful supply, you'll get 3 marks there, and it's efficient, you'll get another 3 marks there. So now let's go back to the question. So we have question A done, so now we'll move on to question B. So in question B, it tells us about crude oil and how it's separated into different fractions in fractional distillation, okay? So B question 1 asks us, what are the two main hydrocarbon components of LPG, okay? And we'll remember what's a hydrocarbon component, and that is a compound which contains only hydrogen and carbon. The second part asks us to explain how crude oil is fractionally distilled using a labelled diagram. And then the third part asks us to show on the diagram where the refinery gas and the gas oil fractions separate. Okay, so this is B, question 1, which asks us for the two main hydrocarbon components of LPG. Now, LPG stands for liquefied petroleum gas, okay? And you're going to get 3 marks for saying propane and butane. Now, this is just one of those things on the chemistry course that you're just going to have to remember. So the two components of LPG, or the two main components, are propane and butane. Okay guys, so now we're going to move on to question B, part 2, which asks us to explain with the aid of a label diagram how crude oil is fractionally distilled, okay? And this question is worth 6 marks in total, but there are a number of ways of going about getting your 6 marks. So the first thing that I've done is I've drawn my fractional distillation column, okay, and labelled it. And I've also drawn the crude oil being heated in a furnace before going into the fractional distillation column, okay? So for either drawing and labeling your furnace or else stating it, as in writing it out like I have on the right, you're going to get 3 marks here, okay? So crude oil is heated in the furnace. You're going to get 3 marks for that. You're also going to get 3 marks if you show or else write again about the column, which is here, okay, with the levels or outlets. So here are the outlets here and the levels here. So you're going to get 3 marks for drawing the column, okay? You're also going to get 3 marks if you show that the temperature decreases going up the column, okay? So to do this, I would draw an arrow up here and just write temperature decreases going up the column. Okay, and you're also going to get 3 marks for that, okay? And if you think about that, that's fairly logistical, okay? Because in the furnace here, it's heated the crude oil, right? So then when it enters the column, it's going upwards, right? So it's essentially losing heat as it goes up, okay? You're going to get another 3 marks if you say that the compounds are separated on the basis of boiling points, okay? So the compounds with the highest boiling points are going to be separated down the bottom, and the compounds with the lowest boiling points are going to be separated up on the top, okay? So you'll get 3 marks for saying this. And then this is just a continuation saying that lower boiling point molecules are separated at the top, okay? So you're not going to get an additional 3 marks for saying that if you've already said the first point, okay? So now you can only get 6 marks, so you're not going to get all 12 marks that I've put out here. So if you say any of the 2 of these, you're going to get 6 marks. Okay, so now we're going to move on to B part 3, and this is worth 3 marks, and it asks us to show on our diagram where the refinery gas and gas oil fractions separate. Okay, so the first thing to note here, that refinery gas is an LPG, which is a liquefied petroleum gas, and gas oil is diesel, okay, because you might remember where these are located on the fractional distillation column. Refinery gas, which is an LPG, has a lower boiling point, okay, and it has less carbons in its chain, so that is going to be separated nearer to the top, okay, so I'm just going to put that about here and write refinery gas. And then for gas oil, which is a diesel, it's going to be under refinery gas, so I'm going to put it somewhere in the middle, maybe here, okay, and write gas oil. Okay, so you're going to get your 3 marks here if you just simply indicate that refinery gas is separated above gas oil. Okay, so now we have question B done as well, and we're going to move on to part C, which just has the 1 question. And it asks us, what is the purpose of adding mercaptans to natural gas or to LPG? Okay, so the purpose of adding mercaptans to natural gas or to LPG is for safety reasons, okay? So it gives gas a smell so that leaks can be detected, okay? So that if there's a gas leak in a house or a school or whatever, that you will smell the mercaptans. It's not the gas you're smelling because gas is odorless, okay? So for saying this, you're going to get 6 marks. Okay, so now we're on the last question. We're on question D. And this is a calculation question, okay? And it is basically calculating the heat of formation of ethanethiol, okay? So what are we told? We're told that the heat of combustion, okay, of ethanethiol, a mercaptan, okay, according to the following balanced equation is minus 1867.5 kilojoules, okay, per mole. And then this is the equation. And we're asked to use this heat of reaction and the heats of formation of carbon dioxide, water, and sulfur dioxide. And then we're given those, and they're all in kilojoules per mole, respectively, to calculate the heat of formation of ethanethiol. Okay, so I have the question out here again. So what is it that we're looking for in this question? Okay, so we're looking for the heat of formation of ethanethiol. Okay, so how are we going to make ethanethiol? So we know that this is what we're looking for. So we're going to need, so I'm just going to say looking for the heat of formation, okay, of 2 carbons plus, okay. We have 6 hydrogen atoms, okay. So I'm going to say 3 hydrogen molecules, okay, because hydrogen typically exists as H2, okay. And then plus S, which is sulfur, gives you C2H5SH, okay. So we're going to use the information that we're given to find this. So the first thing we know that this equation has a heat of combustion, okay, of minus 1867.5 kilojoules per mole, okay? But we want the ethanethiol to be on the right-hand side. So let's just flip this, okay, and then change the heat of combustion to the heat of formation, okay? So when you flip an equation, you have to change the sign. So it's going to be 1867.5 kilojoules per mole. Okay, so I'm going to say what we have. So I'm going to flip this around. So I'm going to say 2 CO2 plus 3 H2O plus SO2 gives us C2H5SH plus 4.5 O2, okay, and the heat of formation is 1867.5. But that's not the only thing we have. We also know that the heat of formation of carbon dioxide, water, and sulfur dioxide. So, carbon dioxide, what do we have? We have carbon plus O2 gives you CO2, okay, and the heat of formation is minus 393.5. Okay, we also know that the heat of formation of water is going to be H2 plus half of O2, because we only need one single oxygen atom, okay? So that gives us H2O. And again, the heat of formation we're given to be minus 285.8. And we also have the heat of formation of sulfur dioxide. So that's going to be S plus oxygen gives us sulfur dioxide, okay? And that heat of formation is minus 296.8 kilojoules per mole. Okay, so what we want to do, okay, is to be able to cancel out everything else except for, and I'll circle the ones now, except for this, and this in these equations. Okay, so what are we looking for? We want to keep this, okay? We want to keep this, and we want to keep 2 carbon, which is going to be here, or carbon here, but that obviously needs to be multiplied by 2. Okay, and also the 3 H2. So what do we need to do? We need to multiply this by 2. We need to multiply this equation by 3. Okay, so let's do that now. So if we multiply by 2, we're going to have 2C plus 2O2 gives us 2 carbon dioxide. And then we multiply the heat of formation by 2. So it's going to be minus 393.5 multiplied by 2. And that gives us minus 787. So let's get rid of this and replace it with minus 787. Okay, so then I'll get rid of this as well so we know that that's done. So now let's multiply this one here by 3. So we're going to have, I'm going to rub this out for a minute. I'm just going to take away all the yellows. Okay, so 3H2, okay, plus 3 multiplied by half is 3 over 2. So 3 over 2, oxygen, gives us 3 H2O. Okay, so now we need to multiply this heat of formation by 3. So minus 285.8 multiplied by 3. And that gives us minus 857.4. Okay, so that's all we need to do. So now let's start cancelling what we can. So I'll just get rid of this on the side here now, so that we're just left with the equation that we're looking for on the top, okay? So what can we cancel? So first of all, we have 2 carbon dioxide on this side, and we have 2 carbon dioxide on this side, so they can cancel. So let's rub those out. Okay, now what else do we have? We have oxygen, so we have 4.5 on this side, okay? And what do we have on this side? So we have 1 plus 1.5, so that is 2.5, plus 2 is 4.5. So we have 4.5 oxygen on the left hand side, and we have 4.5 oxygen on the right hand side, so we can cancel all of those. Okay, now we have sulfur dioxide on the left hand side, and we have sulfur dioxide on the right hand side of the arrow, so let's cancel those as well. Okay, and finally we have 3 water molecules on the right hand side and 3 water molecules on the left hand side, so we can cancel those. okay? So now you can see that we are left with 2 carbons plus 3H2 plus S is equal to C2H5SH, which is exactly what we wanted, okay? So we have 2C plus 3H2 plus S gives us C2H5SH, okay? But we can't just leave it with this equation, right? What we have to do is we have to add their heat of formation, which we have here. So this plus these 3, okay, to find the heat of formation of ethane thiol. So what are we adding? We're adding 1867, my apologies, 0.5 minus 787 minus 857.4 minus 296.8 to get the heat of formation of ethane thiol. So that gives us an answer of minus 73.7, okay, and that's kilojoules per mole, okay? So this then is the heat of formation of ethane thiol as requested, okay? So this question is going for 15 marks. So where are you getting those 15 marks? So you get 3 for your final correct answer, okay? And you get 3 for finding each of these, okay? And they're all kilojoules per mole. So that completes this question. That was a relatively difficult calculation question at the end, but with these, I think my best advice is just to practice doing these, okay, so that the formula of how to do it sticks in your head. So I hope that this solution video was helpful for you and it cleared up any questions that you may have had, and I'll see you all in the next video.